My dear students, today we will be study about the electric field intensity due to a uniformly charged ring or circular disc. Consider a uniformly charged ring of radius small a at center O. We calculate the electric field intensity at a point P due to the uniformly charged ring. Let dl is a small element of charge dq. First, we taken a small element of ring of length dl and charge dq and calculate the electric field intensity due to the element at the point P according to Newton law. Vector D is equal to 1 upon 4 pi epsilon 0 dq upon r square, where D is the electric field intensity at the point P due to the element makes an angle theta. D have two rectangular components. First, perpendicular components d sin theta, and second, horizontal components d cos theta. D sin theta have the equal magnitude and opposite direction, so the perpendicular components neglected each other. d sin theta और d sin theta का डायरेक्शन अपोजिट है और मैग्नीट्यूड सेम है, तो एक दूसरे को निगलेक्ट कर देंगे. Then the net field intensity at the point P d cos theta. The vector d is equal to 1 upon 4 pi epsilon 0 into dq by r square into cos theta, where r is equal to under root a square plus x square according to Pythagoras theorem. Hypotenuse square is equal to base square plus perpendicular square. R is equal to under root a square plus x square. Cos theta is equal to base upon hypotenuse. So base x and hypotenuse r, x by r. Taken the equation 1. Put the value of r square and cos theta in equation first. We get vector d is equal to 1 upon 4 pi epsilon 0 dq upon a square plus x square into x upon under root a square plus x square. Or vector d is equal to 1 upon 4 pi epsilon naught dq by a square plus x square power 3 by 2 into x. The net field intensity at the point P due to the ring. Integrate the integration d is equal to 1 upon 4 pi epsilon naught integration dq upon a square plus x square power 3 by 2. Integration d is equal to 1 upon 4 pi epsilon naught x upon a square plus x square power 3 by 2 integration dq. We know integration dq is equal to q, where q is the total amount of charge on the ring. Q is equal to total amount of charge of ring, and integration D is equal to E net field intensity due to the total ring. Or E is equal to 1 upon 4 pi epsilon naught Q into X upon A square plus X square power 3 by 2. Special case first. If X is very greater than A, then A square is very less than X square, so A square is neglected. Then E is equal to 1 upon 4 pi epsilon naught Q upon X square power 3 by 2, और E is equal to 1 upon 4 pi epsilon naught 2 से 2 कैंसिल हो जाएगा, x से x क्यूब और q by x square. It is the electric field intensity at the point P due to the uniformly charged ring. Second condition, the field intensity at the center of ring, then x is equal to 0 or E is equal to 0. We say the electric field intensity at the center of a uniformly charged ring is always 0. Next, third condition, the maximum intensity on the axis of ring. We calculate the maximum field intensity on the axis of ring. For the maximum value of the field intensity, dE upon dx is equal to 0. जिस पॉइंट पर जो है फील्ड इंटेंसिटी जो है मैक्सिमम वही होगी जहाँ पर dE by dx की वैल्यू जो है 0 होगी. तो डिफरेंशिएट द dE by dx, तो d by dx इंटू ब्रैकेट 1 upon 4 pi epsilon 0 q by a square plus x square upon 3 by 2. We know q by 4 pi epsilon naught is constant, so q by 4 pi epsilon naught into d by dx into bracket a square plus x square power minus 3 by 2 is equal to 0. Or d by dx is equal to q by 4 pi epsilon naught a square plus x square power minus 3 by 2 plus x into minus 3 by 2 into a square plus x square power minus 5 by 2 into 2x is equal to 0. और a square plus x square power minus 5 by 2 into a square plus x square minus 3x square is equal to 0. Neglect the term a square plus x square power minus 5 by 2 is very small. Then a square plus x square minus 3x square is equal to 0. Then 2x square is equal to a square, or x square is equal to a square upon 2, or x is equal to plus minus a by under root 2. So we say the maximum value of field intensity due to the uniformly charged ring at a point of distance is equal to the a by under root 2 times r 1 upon under root 2 times its radius of the radius of ring.